Algebra 2, this is Chapter 6, Section 5. I'm going to talk about the discriminant now, and I'm going to get into the last example also with this, but I need a brief description of what a discriminant is first. So in our quadratic formula, we've got one part here that pretty much determines what kind of answers you're going to have, the square root part to it. So if the part inside here is positive and is a perfect square, then you end up with two real roots. If it's negative, you end up with complex roots. So we have a special name for this, and that's called your discriminant. And you spell discriminant D-I-S-C-R-I-M, discriminant, discriminant. And that's just this part here. So it's the b squared minus 4ac. So when we talk about discriminant, we're talking about just that b squared minus 4ac, which is that part down here. So let me go over kind of what that controls. And it's not actually the square root part. So let me group, ungroup, and get rid of that and get rid of that. So that's our discriminant right there. So if that part is, and why don't I just type it because it works better for me. If it's positive and a perfect square, you end up with two real roots. And let's go. And besides for just real, I believe they're rational. Two real rational roots. Okay, then the other thing it could be positive, and not a perfect square. And then you would have two, and they would be real, but they would be irrational. And just get the idea of what you have here. This would be an answer like 2 and 5 would be an example. So, an example. Let's go. So an example here would be 2, and then we'd need the square root symbol. 2 square roots of 3, and maybe 7 square roots of 3. Because you'd be adding and subtracting that discriminant part, right? Plus or minus. Okay, so there would be 2 irrational roots. What else could we have? We could have, that could be 0, right? So it could be 0, in which case we would have just one real rational root, because we wouldn't be adding or subtracting anything, so i.e. we'd get like 9. And the last thing that could happen is you could have it negative, in which case you would end up with 2 complex roots. If that's negative, then you would have something like Control C, just move that down here. Maybe it would be 2i and 7i. So you'd end up with something like that. Sorry, I'm mistaken. You'd end up with something like 2 plus 3i, maybe 2 plus 2i, and 2 minus 2i. So your complex roots would look something like that. So there would be your 4 possible answers. So let's put this into our table here. So the value of the discriminant, and that's what this says. If this value here is positive and a perfect square, if it's positive and a perfect square, you end up with positive and a perfect square, 2 real rational roots. And you'll want to copy this table down, so you want to pause this video and get this in there. If it is greater than 0 and not a perfect square, you end up with 2 real irrational roots. If it's equal to 0, you get 1 real root. And if it's less than 0, you get 2 complex roots. Again, it's very important that you understand this concept here, because it's going to help you later when you figure out how many answers you have and where exactly you're graphing your quadratic. So in this case, I would like you to pause the video and copy this down. Okay, example that we're going to get into now, third example that I'm actually recording, and the 5th example in the book if you're using the book. We want to know, find the value of the discriminant and what type and how many roots will it have. So we are just looking, remember back to the value of the discriminant, we're just looking at right here, this b squared minus 4ac. So let's grab b squared minus 4ac and see what that looks like. So remember a, b, c. So b squared would be 36 minus 4 times 1 times 9. And so this is going to be 36 minus 36, or 0. And looking at our table, when it's 0, we have 1 real root. So this is going to be 1 real root. And what does that mean? Well, a is positive, so this is a parabola facing up. It's got 1 real root, so it's going to just touch the x-axis and go up like that. And you'll have 1 point on the x-axis. Okay, let's look at another one here. So again, we're looking at b squared minus 4ac. B squared minus 4ac. That is your discriminant. So a is again going to be that 1, b, and c. So b squared is going to be 9 minus 4 times 1 times 5, so minus 20. So we are going to get a negative number, and it's negative 11. And so that means, we go back to our table, if it's negative, we are going to have 2 complex roots. Okay, so this is going to be 2 complex roots. Okay, and 2 complex roots means that we don't have any real roots. So, and it's facing up, so we are somewhere, you know, up here where we don't cross the x-axis at all. Let's look at a third example here. And I've got a fourth one. Yep. So we need b squared minus 4ac, our discriminant. And a is again 1, b is 8, c is negative 4. So we're going to do 64, that's 8 squared, minus 4 times 1 times negative 4. So that's actually going to be a plus 16, right? So plus 16. So this is going to be a positive number. And since it's a positive number, we're going to have 2 real roots. So 2 real. And 64 plus 16, that's 70, 80. 80 is not a perfect square. So if we are not a perfect square, we're here at irrational. Okay? So this is 2 real irrational roots. So you're going to have a parabola. It is going to be facing up because a is 1. It's going to cross over and come back up. But these numbers right here will be irrational. Okay. And we've got one more example down at the bottom I had. Get rid of that. Extend my page. So we need b squared minus 4ac. And so A is 1, B is a negative 11, C is 10. So negative 11 squared is positive 121. Minus 4 times 1 times 10, that's minus 40. So 121 minus 40. The 1 comes down. 12 minus 4 is 8, so that's an 81. 81 is a perfect square. So we go back to our table. So it is a perfect square, so we got 2 real rational roots. Oops, all the way down here. So this is 2 real rational roots. And A is positive again, so we have a parabola. It is facing up.
Good morning, staff.
And it just means that these 2 numbers right here and here will be rational numbers on the x-axis. So just a quick review for you. Here's your quadratic equation. There's your discriminant, and there's your line of symmetry. Make sure you have those. You memorize those. You put them in your notes. You do whatever you need to. But those are going to be extremely important for the rest of the school year, pretty much, because we're going to be dealing with quadratics on and off.